Dear students, I welcome you to this lecture. It is all about the famous classical conditioning theory of learning by the famous Russian physiologist Ivan Pavlov. The theory of classical conditioning owes its origin to the discovery of the distinguished Russian physiologist and Nobel Prize winner Ivan Petrovich Pavlov, who is credited to give psychology a scientific upliftment by advancing his theory. Since his observations and experimentations were objective, unique and interesting, he deserves the tribute of providing a scientific platform to the field of psychology. His findings have brought about a revolutionary change in the field of learning. His outstanding contribution to psychology is that he showed how a part of the environment can control a subject's response, though normally it should have no connection with it. How learning takes place or is acquired, he proved it in an objective way and considered the process of conditioning as sufficient to explain all forms of learning. He emphatically writes, "Different kinds of habits based on training, education and discipline of any sort are nothing but long chain of conditioned reflexes. Conditioning is the establishment of connection between a stimulus and a response which have no natural connection between them. As an associative form of learning, it holds that the formation of stimulus-response connection, its strengthening or weakening depends upon association of two things. While studying relatively automatic reflexes associated with digestion, Pavlov noticed that a dog salivated not just when food was placed in its mouth, but also at the sight of food or an empty plate. This experience led Pavlov to the famous, widely referred and quoted classical experiment on classical conditioning. To understand the conditioning in detail, Pavlov designed the experiment on a hungry dog tied to the experimental table, fitted with certain mechanically controlled devices. Initially, food was presented to the dog and the dog salivated. Here, presentation of food was purely natural, unconditioned stimulus, an unconditioned external event, and the salivation in response to food, a natural, glandular, and unlearned response. Of course, we may call it a reflex, reliably elicited by the natural and adequate environment, that is the unconditioned stimulus. At the next step, a neutral stimulus, that is the ringing sound of the bell, was presented alone, and there was no pronounced effect of bell sound upon the dog except a little turning of the head towards the bell sound. At the third step, the neutral stimulus, that is the ringing of the bell, was combined with the presentation of the food. The experimenter rang the bell just prior to the presentation of the food, and this pairing of the bell and food was done several times. After this process was repeated several times, the experimenter rang the bell without the presentation of the food and found the dog salivating. What happened to the dog? The dog could connect the bell with the food and anticipated food at the sound of the bell. This means eventually, after repetition and the correct time relationships, the sound of the bell evoked salivation independently of the food. The bell is now referred as a conditioned stimulus, CS. Salivation in response to the ringing of the bell is designated as a conditioned response, that is CR. All this process can be explained by this pattern. Dear students, you can look at the screen. It is natural or unconditioned stimulus, UCS, that is the food. It leads to a natural or unconditioned response, that is UCR, saliva. Conditioning second, or you may call it stage second, it is conditioned stimulus alone is presented, that is bell, and it leads to no salivation, that means to no response. Condition 3 is repeated for several trials, that is bell and food is presented together until an association is established between conditioned stimulus and unconditioned stimulus, and certainly it leads to an unconditional response, that is saliva. And the experimenter presents at the fourth stage bell alone, that is the conditioned stimulus, and what happens? There is saliva, that is CR is established. The experiment highlights that a neutral stimulus got changed as a meaningful stimulus by the process of association and gained the characteristics of eliciting a response. The dog's behavior got changed, and this change happened as a result of conditioning. Conditioning is the process in which a neutral stimulus, by pairing with a natural stimulus, acquires all the characteristics of a natural stimulus. As Guilford's terminology puts it, here's a quote: "The most simple interpretation of this phenomenon is that when two stimuli are presented repeatedly together, the new one first, then the original one, effective one, the new one also becomes effective." Or here is a quote from Hilgard. He describes it: "Classical conditioning is the formation of an association between a conditioned stimulus and the response through the repeated presentation of the conditioned stimulus in a controlled relationship with an unconditioned stimulus that originally elicits that response. The original response to the conditioned stimulus is called an unconditioned response. The learned response to the conditioned stimulus is called a conditioned response, that is CR." Dear students, let us shift to some of the phenomena of classical conditioning which form the core of this learning theory. First, it is contiguity and reinforcement. Contiguity means simultaneous presentation of neutral stimulus and natural stimulus. It is this pairing of the two stimuli that becomes an essential operation in classical conditioning. Closeness of the two is related to the concept of pairing. In this context, temporal relation between the two stimuli becomes an important factor. It is to be noted that in conditioning technique, the CS, conditioning stimulus, precedes the US, that is unconditioned stimulus. Conditioning is strong and effective with shorter latency period, that is near about 3 seconds, as the studies show. Repeated pairings with appropriate time gap is a necessary condition for observing the stage of acquisition. The response to the conditioned stimulus, that is salivation, in response to ringing of the bell becomes stronger with the number of pairings of food and bell. The unconditioned stimulus functions as a reinforcer as it strengthens and maintains the association between the conditioned stimulus CS and the conditioned response CR. A reinforcer is a stimulus that strengthens or maintains the occurrence of a behavior. In classical conditioning, the UCS both elicits the response to be learned and also functions as the reinforcer. As a matter of fact, if this reinforcer is terminated, extinction of CR will take place. Students, Now let us know what this extinction is all about. Experimental extinction is the process through which the conditioned stimulus gradually loses its properties of evoking a conditioned response. After the stage of acquisition, if reinforcement is discontinued, that is, the conditioned stimulus is presented alone repeatedly unaccompanied by the unconditioned stimulus, the conditioned response gradually diminishes and disappears, or we can say that extinction takes place. Thus, the acquired CR ceases or gets extincted. Thus, if the bell that has been eliciting salivary response is rung without presentation of food, the amount of saliva decreases gradually. Finally, there is no response to the conditioned stimulus. The salivation will practically be zero, which will indicate the operation of the phenomenon of experimental extinction. The process of extinction makes it clear that conditioned responses are not necessarily permanent, and what can be learned can be unlearned. But extinction of CR is not forgetting or erasing of what has been learned. It is rather the matter of inhibition. Extinction is the process of learning to inhibit the response acquired in conditioning. The phenomena spontaneous recovery and reconditioning do evidence the fact that acquired CR is not forgotten altogether. In the process of extinction, it is rather inhibited. Spontaneous recovery. The phenomena of spontaneous recovery refers to the reappearance of an apparently extinguished conditioned response after an interval. This focuses on the fact that in extinction phenomenon, the conditioned response is not completely or entirely erased, rather not responding is a matter of inhibition. Pavlov found that once the flow of saliva was completely extinguished, after about 30 minutes of rest interval, the dog again salivated to the conditioned stimulus without unconditioned stimulus. This reappearance of the extinguished conditioned response after a brief rest clarifies that all is not forgotten during the extinction session. Although the reappearance of extincted response may not be in its original strength, but it does evidence that the animals tend to retain some of the learning association formed by originally pairing of conditioned stimulus with unconditioned stimulus. Thus, the extinguished conditioned response spontaneously reappears after the rest interval when conditioned stimulus alone is present. How much is the amount of spontaneous recovery depends upon the duration of lapsed time after the extinction session. The longer the duration of the lapsed time, the greater is the recovery of acquired conditioned response. Thus, it becomes clear that learning is not forgotten rather than suppressed, and it is the main idea present here. Here is another phenomenon, reconditioning. Besides spontaneous recovery, reconditioning is another phenomena that supports the concept that extinction is just the process of inhibition. After extinction, when a reinforcement is again provided, that is, pairing of CS with UCS is again established as it was originally established during acquisition, reconditioning occurs. Pavlov found that reconditioning occurs more rapidly than the original conditioning. This means that relearning an association is faster than originally learning it. The process of extinction and reconditioning make an organism to learn both kinds of responses, to respond and not to respond. Putting it differently, one learns when to do and when not to do. Stimulus generalization. Generalization is the process whereby a conditioned response established to one stimulus may also be elicited by other similar stimuli. This means that once conditioned response has been acquired, situations or objects similar to the original conditioned stimulus evoke the same reaction. The more similar the new stimulus, the greater is the probability for generalization, and vice versa is also possible. Less similar stimuli assure a lesser probability for generalization. The strength of response evoked by the generalized stimulus will depend on how similar it is to the conditioned stimulus. A conditioned response established to a specific conditioned stimulus will be made also to the other stimuli which more or less resemble that specific conditioned stimulus. If an experimenter used an electric bell sound to establish the conditioned response, a school bell, buzzer, etc. can be substituted, not denying the fact that the response would be little weak. Generalized gradient is a concept which refers to the fact that these substituted stimuli are less effective the less they resemble to specific conditioned stimulus. Pavlov noticed the dogs that had been trained to have a conditioned response to a certain tune would show the same responses to a tune that was slightly higher or lower in pitch. Albert, a 9-month boy, one of the subjects of Watson, was conditioned to show fear reaction to white rabbit, could even show the same reaction to a white fur coat, bunch of cotton, and to all other stimuli having similarity to white rabbit. Stimulus generalization can enable organisms to adapt better to the environment. A child who has learned to withdraw after touching a burning flame will tend to generalize this withdrawal to another stimuli that are similarly bright and hot, like electric burners, etc. Organisms might not be exposed to exactly the same stimulus very often, but similar stimuli are likely to predict similar events. Here is another phenomenon. It is stimulus discrimination. Whereas generalization is a reaction to similarities, discrimination is a reaction to the differences. In contrast, to respond in a similar and unusual manner, the subject learns to react differently in different situations. The subject learns to be selective and discriminative in responding to the correct stimulus. Differentiation develops out of generalization. Conditioning involves general and undifferentiated behavior at first, followed by greater precision after discrimination. In terms of Hilgard, a process complementary to generalization is discrimination. Whereas generalization is a reaction to similarities, discrimination is a reaction to differences. Conditioned discrimination is brought about through selective reinforcement and extinction. In one of his experiments, Pavlov used bell sound as well as buzzer sound, and initially both elicited salivation, that is conditioned response. Here it is a case of generalization. But on reinforcing repeatedly only the bell sound with food, he found the response to the buzzer sound gradually weakened and extinguished because it was not reinforced. So, discrimination is the overcoming of the initial generalization by use of selective reinforcement. I will cite an example here. A child who generalizes every woman as his mother gradually discriminates and calls the only woman his mother, who nurses, feeds, sleeps with him, and takes care of the child. Generalization and discrimination occurs frequently in everyday life. Children do exhibit discriminative learning when they differentiate alphabets, geographical figures, etc. Experimental evidences show that both animals and human beings can learn fine discriminations. Here is another phenomenon, higher order conditioning. When conditioning is done to a new stimulus on the basis of a previous conditioned stimulus, it is designated as higher order conditioning. Putting it differently, higher order conditioning is a process whereby a previously established conditioned stimulus is used as if it were an unconditioned stimulus to create conditioning to a new stimulus. When a new CS conditioning stimulus, that is conditioned stimulus 2 CS2, is paired with previous conditioned stimulus, that is conditioned stimulus 1, and acquires the ability to elicit a specific response, it is called higher order conditioning. In one of his experiments, Pavlov first trained a dog to salivate to the bell, that is conditioned stimulus 1, using food as unconditioned stimulus. Once conditioning was established, he introduced a new stimulus, light, that is conditioned stimulus 2, which was repeatedly paired with the sound of the bell when no food was presented. After several such pairings, presenting the light alone tended to elicit salivation. This can be represented by this paradigm. Students, you can look on the screen. Original conditioning, that is conditioned stimulus 1 bell is paired with unconditioned stimulus, that is food. When paired elicits salivation response to conditioned stimulus 1, that is bell. In the second order conditioning, conditioned stimulus 2, that is light, is paired with conditioned stimulus 1. Here, conditioned stimulus 1 acts as unconditioned stimulus, that is the bell. When paired, elicits salivation response to conditioned stimulus 2, that is the light. Thus, a newly acquired strength of bell can also be used to condition the same response to other stimuli. Here, in this case, it is the light. The existence of second order conditioning greatly increases the scope of classical conditioning. Especially in humans, most conditioned responses are established through second order conditioning. Here, we are having another phenomenon of classical conditioning. It is experimental neurosis. The phenomenon of neurosis has been studied on the basis of the processes of generalization and discrimination. Sometimes the differences between the stimuli are so slight and minute that an organism fails to discriminate. Due to conflict, the organism becomes non-adaptive and is unable to respond to salivate. This situation leads to the experimental neurosis. In an experimental situation, a dog was made to discriminate between a circle and an oval. After the dog learned to discriminate, the oval was gradually made more circular. This minute difference between the two stimuli enabled the dog to respond, became upset, appeared fearful and wild, barked and struggled, leading to abnormality and behavior disorder. An organism in experimental neurosis faces a clash between positive and negative forces to or not to salivate. Children and even adults exhibit similar behavior when they are pressed to discriminate beyond their capabilities. Sometimes you might have seen students in the examination show such type of behavior when they are asked to answer two similar types of questions with a slight different approach. The very concept of experimental neurosis, which throw light on various abnormal behaviors, has opened new avenues for research, and researchers have conducted many experiments in this regard. Going through all the major classical procedures or phenomena, one gets an idea of the key ways in which organisms learn. Since the times of Aristotle, philosophers have been recognizing that learning is largely based on forming associations or links between events. But it was the Russian physiologist Ivan Pavlov who was the first person to apply careful scientific methodology to study the process by which these links are established, modified, and broken. Definitely, his work on conditioned responses discovered the way of studying the behavior with more objective techniques. How animals and humans can be taught to react in a definite way to a particular stimulus is what Pavlov's major work describes. Dear students, let us back up here, and I hope that you might have understood the basic crux, the basic essence of the famous classical conditioning learning theory. Thanks.